guess I'll be going somewhere to get it.
Is there many students in this class?
In here, it's just me and one.
Alrighty.
I know that we were talking to Dave, you're a school teacher.
Small class, actually.
Ohio, or you're a state worker, or whatever.
I'm not going to zoom in on you too much. Do you talk much in this class?
No, it's mostly just lecture.
I don't know if it's true.
You guys ever want to bring food in here and eat it? I can always mute it so you can hear it. Okay, just in case. It's this that weird behind in between lunch.
Yeah.
Lunch or
Yeah. And I have a class right after this until 2, so it's like.
So
yeah.
I can always mute it so he doesn't hear you.
Alright, cool.
I think I got the survey. I think it's not just too bad. It's just,
What time is
I think it ends at like, we ended early today. It usually ends about 10.
Because I didn't show up.
It's okay, we were locked out of the classroom for right about then. Even as already in that conversation, probably about 2, 3 minutes later.
So is the microeconomics is the guy on the cheap thing? Can he?
Just like we can
A little nervous like nobody was going to show up.
Huh?
Just getting a little nervous like nobody was going to show up.
That's what happened on Monday. I showed up at like 10:42 something. And we showed up right before. I'll come.
Oh, they have classes.
I just need to.
Right back tonight. Mondays.
Did you understand all of this?
I did. I wanted to kind of check it.
I know when I was.
Did you do it?
I did it.
I deliver newspapers, and I would go and look at I'm floating out time. That's the last. That work I did. Hang on for it. This one, Monday, Wednesday,
So I didn't do that.
Taking
Reuse parentheses. I wasn't sure about that either. I just did that push other truth table. Could ask her that. I guess so. And then
But whenever I get in college, I'm going to be applying for
make you some money.
hopefully.
Maybe we'll start finding
I did this.
area like sports or all.
I haven't quite decided yet. I know when I did surgery a few years ago.
Name the check.
Actually, this deal
Is it this one?
he didn't know.
Yeah, they're still the same.
What I did.
They're still like what?
I was gonna check it.
Hello. Just updating some of the older
Oh,
stuff.
checking with you.
Did you listen to our
I
video?
studied.
Yeah. So on,
Okay.
I took further grade.
I mean,
class
you
this
know,
summer, and it's like the same.
They only take two.
Written question, no question, post something.
Oh, that's so much
And it's not the same.
I'm just not
Right.
up there because I can't believe.
That's the only reason why I could do this.
I got shared custody of my kids. If I had full custody, then and getting my degree it's hard because I found it's easy for me to go through the instead of trying to cram.
Guys gonna go to Macy's again?
What is class after? Or,
You can enjoy it more.
Did you do your?
yeah.
It wasn't. You just like it was a paragraph.
So now, is that an all-American band or is it all you all get together?
I'm an all-American.
Oh, anybody else? You all go?
We have a kids.
Oh, that's good. See, have you,
He specifically
the
said.
first two times were all the kids the same? Like you
The
friends
first,
with
the
them?
first time I went, I was the only one.
Oh, what about like have you met friends from other schools and stuff?
Oh yeah, yeah. I made a group of friends and we all met up this summer in Virginia.
Oh, that's cool. That's one thing good about social media. Social media
Did you watch the?
contact,
Yeah.
stuff like that.
I didn't get 36 my first time. My first
Did you do it?
Wow.
I was like,
I'm surprised.
Give college.
I
Go
would.
straight up to certification.
It's not.
I know, it's like, geez,
It's just the.
You only ever college visits?
Go to all the Ivy League.
Oh, you went through all of them? So what's a good bit?
Yeah, touchdown.
I was the other best.
Yeah, still the best.
semi-study.
So you went to Penn, what else?
Yeah,
Brown?
we have a
Yeah.
very long time like this.
Boston Show Runner.
Was it like second?
I'm saying college. Just like,
Harvard. I really liked Harvard. She liked MIT.
Yeah, this is nice.
Providence for a wedding. Her friend went to Brown.
That's the only reason.
English and
And you have a 36 on the way.
What town was the prettiest?
he said the entire
You know?
Is that what you make this?
That's in New Jersey.
Yeah.
It's in New Jersey.
We did do these. Logically.
Wow.
Next. This The one with only one screen, and I didn't know there were any other rooms open. No, I think we got it. I got it.
That's what I glanced at.
That's where all of our scholars
If this is what we're doing.
mainly for health, and then I'll decide where I actually
And you just want to go straight into the organization, you go do certain.
The video.
understand all
Oh.
of the right.
Yeah, I was seeing it as like a help.
Yeah, maybe.
I feel like that's
What the parentheses? Yes.
It would be interesting.
Right?
I mean, you. Gonna have a break here or a break over there.
Did you watch the
No, that's it.
What's that?
And a glitter sequin.
Did you get yours?
Yeah.
he's not collecting them, so. I think we're more just like sharing our ideas. He wants like a solid paragraph. Talking about it being type capacity. Yeah.
I thought
Maybe I didn't know.
also
Because on the key, what he did, just that's all.
probably the same thing. I just
Good morning, Dr. Shan. How are you? Good.
Some of my friends, they come from other institutions, so they know.
Correct.
He was
They think German.
and so we have to get
So I looked at the magnet. So many weird rules.
I was doing something else.
I also
Yes.
I feel like most of it seems pretty simple.
All right, can everybody see the Blackboard screen?
No.
no.
No? I have the other campus. All right, what about now?
Yes.
Okay, great. Okay, so let me try to call everybody's name first. Megan. Here. Austin. Elsa. Here. Elisa. Oh, sorry, Allison. Here. Katie.
Here.
Danielle. Elena. James. Jesse. Here. Jeremy. Oh, wait, sorry, I should. Morgan. Wait, here. Okay. And Leah. Here. Catherine. Here. Madison. Here. Curtis.
Here.
All right. Okay, let's get started. So the homework list is posted under week 1. On Monday, I covered 1.1. I think the homework question, like if you don't have the textbook or if you have a different version, you can click on homework and to find the typed up questions there. So you should be able to do, I did give you examples for 24, 29, and 37. Number 8, I didn't really give you any specific example like this. Have you tried homework questions yet? Yes?
Yeah. We were wondering for number 8, did you want us to use parentheses to kind of make it more
Yes, if it's needed.
Okay.
For example, let's see, like in the part E. In some cases, you don't need a parenthesis. Let me, for example, if you have, that is camera. So, if you have a P and a Q or R, in that case, usually we follow from the left to right. So if you don't put parentheses for the first two, that's okay. But if you put then, it's put the parentheses there, it's never wrong. To emphasize, you do that first. But in some cases, you have to. Well, for example, if you want to do Q or R first, you have to put parentheses there because otherwise we assume you're going to do follow from the left to right order. And I think the one that part E, the second part, first part, but he is not both healthy and wise. Not both. Okay. Well, there are two different ways to write the answer. So it really depends on how you write it. In one case that you have to use, if you keep the what they have originally, not this and that, you do have to put parentheses for those two. Okay. For example, when I say it's not rain and snow. So in this case, rain and snow. So I have R for to represent rain. That's for and. That's for snow. Not both of them. Not both rain and snow. Then I put not. So the symbol is that, and you got to put parentheses for that because it says not both of them, right? So you should put parentheses for both of them because this not is in front of both. Do you see what I mean?
Yes.
Okay. That's the case. Well, but we learned at the end of the class last time, we talked about De Morgan's law. And you could use De Morgan's law to rewrite this. What is the negation of a conjunction, an and statement?
Or
Yes. What can you tell me? What would this be?
not
rain or not snow, right? So if you want to give me that, that is also correct. So in that case, you don't need parentheses. But it's up to you. So you don't have to do that. Using the Morgan's law to simplify it, you can just keep it the way it is, or if you like that way. But if you want to do that way, make sure you have to change and to or. Okay, because not both. What does not both mean? Not both means one of the conditions, at least one of the conditions does not occur, right? So it could be not this or not that. Okay. Other questions?
Yeah, I have a question about 24. It said to include a few words of explanation. Do you just mean, we just wrote the problem, then just wrote are logically equivalent, but did you want anything specific?
Well, if you draw the truth table, and how do you check they are logically equivalent? How do you know after you make the table?
If the two columns of the table are the same?
Yes, that's right. That's all you have to say.
Okay. Okay. Thank you.
Mm-hmm. Other questions?
Yeah, actually for number 29, where you have to use that law,
De Morgan's.
De Morgan's law. Do you want us to also write it out in symbol form or just sentence form?
The answer will have to be the sentence in sentence.
Okay.
You can use the Morgan's law, the symbols, to help you if you cannot see what the answer, but I think most of you probably can already see. So you negate the first part, you change and to or, and you negate the second part, right? So that's pretty much what the Morgan's law is. Okay. But the answer has to be in sentences. You can use symbols to help you, but the final answer must be written in sentence. Okay. Other questions? No? Okay. So do you don't need me to give you an example for number 8? You can. Okay. Well, so because this is we kind of did some of the questions similar to that. It's not exactly a specific example, but if you have questions, if you have trouble doing this, and you can ask me next Wednesday in class at the beginning of the class, and I can give you example if you need it. But if everybody thinks it's easy, and I will not give you examples for that. All right, now let's move on to section 1.2. Well, in 1.1, we talked about the main statements, compound statements we talked about are those three here. Let me show you. So we had negation, we had conjunction, which is like and. Disjunction, it's like an English word or. We talk about truth value. So to create a truth table, to do those, to find out whether a statement is true or false, especially when you have a very complicated statement. So today we're going to introduce in 1.2 a new type of statement, which is called a conditional statement. Sorry about that. Okay, so let's go back to the section, conditional statement. I'm going to give you an example. Say, in real life, we say this all the time. If this, this, and then that, that, right? So that's called a conditional statement. So usually the definition is if such and such is known, maybe move it down here. So then something or other must be the case. We use symbols. Such and such is known. We can use the letter P because that's a statement. Again, we're talking about compound statement because you have more than one simple statement. We use P for that, and something or some other must be the case. That's called Q. And we can use P, if P, then Q. We use an arrow to point to Q. So if this, you can read it as P, if P, then Q, P implies Q, Q is implied by P. Many different ways to say that. Okay, so that's a simple way to write a conditional statement. And P right here, the sentence or statement that's after if, the word if, we call it hypothesis. Let me just maybe mark down here. And the sentence after then, we call it a conclusion. Or a consequent. Hypothesis, you can also call it antecedent, but most of the time I would just say hypothesis and a conclusion. Okay, so we can look at some examples here. So if you go to a job interview, and after the interview, the person who interviewed you told you, if you show up for work, Monday morning, then you will get the job. Right, so this is a conditional statement. So when can you get jobs? So if you show up for work Monday morning, so that's the hypothesis, or under that condition. Or I could say if like 6 syllables, if you get average of 93 or higher, you will get an A, and that's also a conditional statement. So if it snows, the class will be canceled. So there are many examples like that. And next thing we're going to talk about is the truth table. And there will be a little bit of confusion right here when we do the truth table. So notice conditional statement, we always have a hypothesis P and a conclusion Q. Whether the sentence is true depends on the truth value of the hypothesis and conclusion. Okay, so first 2 columns are created. P is the hypothesis, and that's a sentence. It could be true or false. Q, it's a sentence, could be true or false. Should be, as we know from Monday's class, when you have 2 statements, there will be 4 possibilities. Both are true. P is true, Q is false, or P is false, Q is true, or both are false. Okay, now our question here is if the hypothesis, both hypothesis and conclusion are true, will the whole conditional statement be true? Okay, suppose let's say that's the boss, the owner, and the boss told you, if you show up for work Monday morning, then you will get a job. Let's say you did show up for work on Monday morning, and he did give you the job. He or she did give you the job. So he kept his promise, right? The conditional statement that you would say, okay, what you told me is true, right? Okay, so that makes sense. But the second one, will also make sense. I think the confusing one will be the last 2. These 2 will be a little bit confusing. So what if you did show up for work on Monday morning, but he did not give you the job?
It's false.
Then you would say, yeah, that would be false. What you said was wrong. You didn't, keep your promise. So that would be false. Well, what happens if you did not show up for work Monday morning? Whether he or she still gave you the job, or he or she did not give you a job, what will make the original statement true or false? If you did not go to work on Monday morning.
True.
So I got 2 different answers, okay? Why do you think it's true, James? False? Oh, you said false? Okay. Why do you think it's false? If you did not show up for work and he did not give you the job.
So if he gave you the job but did not show up for, but you did show up for work, even the first one itself?
Well, okay, we can start with the first, this one here. So you did not, false means you did not show up for work Monday morning, and he still gave you the job. Would that be?
All of the statement's false, right?
You say it's false?
Yeah. He said if you show up for work, then you get the job. If you don't show up for work, then you wouldn't.
But, okay, so this is a common misconception right here. A lot of times when we say that when you hear someone say that in real life, you automatically assume if you don't show up for work Monday morning, you will not get a job, right? That's what we always assume. In real life, that's sort of the common sense that everybody thinks that way. But in mathematics, it's not like that. I can give you sometimes it is true, but sometimes it's not. I can give you an example. If I live in Columbus, then I live in Ohio. But if I don't live in Columbus, does that mean I don't live in Ohio? No, that's not true, right? So in some cases, it may not be true. Okay, I think, yes, in real life, a lot of times if you hear someone telling you that, yes, it means if you don't show up, you won't get a job, right? But that's not always the case, okay? So don't make any assumptions. So right here in math, whatever you see is whatever they tell you can only assume. If they don't say, if you don't show up for work, don't assume you don't get a job. If they don't say that, tell you that specifically, okay? Because they're possibly, if you don't show up for work, maybe you were sick or something, you called in and called the boss, and then he or she just tells you, okay, well, I will still give you a job. It's possible there are other situations, right? Okay, so that's not assumed the other way. And so in this case, that would still be true, okay? If you don't show up for work and they still gave the job, that would still automatically consider, well, we actually, by default, we still consider that is true. And the same for the other one. You don't show up for work and you don't get a job, that would still be considered as true, okay? So these two are sometimes will be a little bit confusing. What you need to remember when the hypothesis, P is the hypothesis, when the hypothesis is false, by default, we consider this whole conditional statement always true, okay? Because this you can think of this way, they only tell you if you show up for work, what's going to happen. They didn't really tell you exactly if you don't show up for work, what's going to happen. Okay, so, all right, the example the example I gave you, I will keep using it again and again later, and because this against against our common sense, what we do in real life. You got sometimes, like I said, sometimes it is true, sometimes it is not. So if I live in Columbus, then I live in Ohio. Don't assume if I don't live in Ohio, then I don't live in Ohio. And many times you read an article, you see they say, okay, if you eat healthy and exercise, then you will live longer. But does that mean if you don't eat healthy, you don't exercise, you will not live longer? Okay, maybe a lot of us assume that, but they didn't really say that, okay? So there are people who don't exercise, don't eat healthy, they still live very long. It's possible, okay? But I know that sometimes we just automatically assume if you don't do this, then that is not true, but that's not the case, okay? All right, any question about this? So that's the truth table you have to remember. Well, if you look at the table again, when will a conditional statement be true? This is the conditional statement. When will this be true? Only when, not only when. If the hypothesis is true, whether the conditional statement is true depends on the conclusion. If the conclusion is true, then the whole statement is true. If the conclusion is false, then the whole statement is false. But if the hypothesis is false, we don't know that, then you always, the whole conditional statement is always true. We always assume it is true.
It always depends on if the conclusion is true or false.
Not always. It also, if the hypothesis is false, we don't even need to worry about the consequence. Like if you don't show up for work, whether you get a job or not, doesn't matter anymore. Okay, we always consider that is true. Okay, so that whole statement is always true. But if the hypothesis is true, you did show up for work, whether this conditional statement is true or not depends on the consequence. Okay, all right. Other questions? So that's the truth table. So later we do have to use this, especially pay attention to the last two cases. Now let's look at the next part, the truth table. Logical equivalence involved in that. So this is similar to what we did on Monday, but we are going to involve logical equivalences involving conditional statement. So previously, on Monday, we did questions like this. Like in your homework, you also have questions like this. So construction, the truth table, you can see whether this complicated statement is true or false. But what we did before was we had conjunction, disjunction, negation. And now we're going to add one more in there, one more operation, the conditional statement or implication. So let's look at example. Let's see. 1.2.2. There in the textbook they have more examples. There's 1.2.1. That's an easy one, so I'm going to go ahead and skip that one, and we're going to look at 1.2.2. So we want to do P. We want you to show P or Q. If P or Q, then R. It's like if this or that. If it snows or rains, then the class will be canceled. So sort of like that kind of sentences. Is equivalent to P implies R and Q implies R. If you think about it, this is not really very complicated. If you think about it, using a real life example, it makes sense. So if P means snow, Q means rain, R means cancel classes. So it's like saying if it rains or snows, then the classes will be canceled. That is equivalent to saying, well, if it rains, then the class will be canceled, and if it snows, then the class will be canceled, right? But we're going to draw, again, like very complicated ones. You may not be able to just use a real life example to see whether they're equivalent or not. And so we're going to do join truth table will always help you. Right here, the first thing you do, if you still remember the examples we did on Monday, so the first thing you always look for those simple statements like P and Q. You created 2 columns for that. But in this case, we have P, Q, R. There are 3 simple statements. So we have to create 3 columns, 1 for P, 1 for Q, and 1 for R. Well, for 2 statements, we have 4 possibilities, different combinations. True, 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 false, false, true, false, false. But for 3 statements, how many different possibilities do we have?
8.
8. Okay. When you list those 8 different possibilities, in one of the later chapters, counting techniques, we will talk about why there are 8 of them. It's actually, a quick explanation is this. How many truth values are there for P? 2, right? True or false. So 2 here, the same for Q. 2 here, R, so 2. So 2 times 2 times 2 altogether will be 8. Okay. Well, when you list them, try to follow a certain order. It's not, because for 2 of them, there are only 4 possibilities. It's hard to miss one of them or repeat one of them. It's possible for when you have 8 of them, it's very possible that you miss one or you write something, one combination twice. So let's follow a certain order. If you, the way I usually do is true, 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 all of them true, and then true, true, false, and then true, false, true, true, false, false. And then we're going to change P to false. False, true, true, false, true, false. 2 more. False, false, true, false, false, false. You don't have to do this order, but I want to show you a way that can help you to avoid mistakes. Because I did notice in the past that some students like missing one or having something twice. So one way you could do is this. It's like a tree diagram. You may have learned in other classes. So you have P, Q, R. So first you write down all the possibilities for P. There are only two of them. Either, so it looks like a tree you start from, but you grow the tree this way, horizontally instead of vertically. So you have, I guess you can do the vertically if you do the other way, but I'm going to show you this way. So for P, there are two possibilities, either true or false. And for Q, there are also two possibilities, but for when P is true, then Q has two possibilities, which is true or false. When P is false, there are still also two possibilities for Q, true or false. And then we're gonna work on R. So when P is true, Q is true. So you keep adding branches to this tree. R has two possibilities, true or false. Similarly, when P is true, Q is false. R still has two possibilities, true or false. The same for the others. When you have all of these listed, I guess if you look this way, if you grow this way, it kind of like it looks like a tree. Tree branches grow in, and when you write it, you could do this. So follow a certain tree branches. So if you go this way, you get true, 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 which is what I have there. And then you grow this way, true, true, false. You get true, true, false. And then you have true, false, true, true, false, false. When you follow the tree branches, you have true, false, false, which is what so the way I did, the order I did is kind of following this tree. So you do it false, true, true, then false, true, false, 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 true, and false, false, false. Okay, make sense? Yes. Like I said, you don't have to do this way. This is not the only way, but I think this will be helpful if you cannot just write down everything. This will definitely help you to avoid mistakes. Okay, now we are ready to work on the truth value statements. So this is the equivalence relation. Let's work on the left-hand side first. We have a new symbol now, implication. So previously we didn't talk about. We just said, okay, you always have to do negate parentheses first, and then what? Remember the order? Parentheses first, and then what? Negation, and then well, pretty much that's it, and left to right. But when you have implication, or if-then statement, what's the order? And this is always the last thing you do, last step, last operation you do. Okay, so when you have this, well, if we follow left to right, unless they have parentheses, okay? So when you have this, well, you're going to have to do P or Q first. And then you do that next symbol. Even if they give you something like this, P implies Q or R. Suppose they give you something like this. If you follow from left to right, you have to do if-then statement first, right? P implies Q, then do order. No, you're not going to do that. And you're going to always do this the last. Okay, you have to do P, Q, or R before that. Okay, so new thing. The implication always the last step you do. Unless they're parentheses. If you look at the right-hand side, they're parentheses. So you're not going to do this last, okay? Parentheses always go first. So you have to do this implication, that implication, and then do and. Okay, so let's work on the left-hand side. So first thing I'm going to do P or Q. Can you give me the... Can someone give me the truth values of P or Q? True.
True.
Mm-hmm.
True. True.
Uh-huh.
True. True. False. False.
Yes, good. Any question about this? All right. That's what we talked about last time. Yeah, for or statement, if one thing is true, then it's true. If both of them false, then you get false. Now we're going to do the next step, the implication. All right, that's something what we just learned today. P, what is the hypothesis? Hypothesis is P or Q, which is this column right here, hypothesis. Okay, the conclusion, R is right there. So be careful, the order is a little switched. That's the conclusion. So this one is our hypothesis, and this one is our conclusion. Now let's look at one by one. Hypothesis is true. Conclusion is also true. That will make this conditional statement
True.
hypothesis is true, conclusion is false. False. And hypothesis true, conclusion true. True. Hypothesis true, conclusion false.
False.
Okay. And then true, true, false,
False.
false. Now the last two, that's the one we gotta be careful. If the hypothesis is false, do we need to look at the conclusion? No. The conclusions don't matter anymore. It's always automatically considered true. Okay. Right. Okay, question? All right, so that's the left-hand side. We got the truth values. Now let's look at the right-hand side. Parentheses go first. We have to do P implies R. And then we have to do Q implies R. Then we also have to do P implies R. The third operation is the conjunction. So I'm going to go ahead and write down all the operations we need to do here. Start with the first one. P implies R. So you're looking at the first column and the third column. So the other difficulty is when you have so many columns, you might look at the wrong column. That could give you a wrong answer. So be very careful with that. And so this time I'm going to do a little faster. Not going to be one by one. P is the hypothesis. When you look at the hypothesis, if the hypothesis is true, the truth value of the conditional statement is going to be the same as the conclusion, right? So all I have to do is copy the truth value of R, which is the conclusion. Okay, right? Okay, now, if the hypothesis is false, I don't even need to look at the conclusion anymore. I would just put what?
True.
It's always true. Okay. Now, similarly, we can do the Q implies R, the second column. So if Q is true, hypothesis is true, it's going to be the same as the conclusion. But if the hypothesis is false, it's always true. Conditional statement is always true. And the same here, the same there. All right, the last step, we're going to do the AND, which is discussed on Monday. So for AND, we need both of them to be true to get it true. So these true and true is true. False and false is false. True and true is true. False and true, that will be, if one of them is false for AND statement, what do we get?
False.
False, yes. Okay, so that's true and true is true. True and false, that's false. True and true is true. True and true is still true. Now next, let's look at the columns we want. This is the left-hand side, and that's the right-hand side. Let's see if they match. And they do match. Okay, so you can say the columns, these two columns have matching truth values. That's why they're equivalent. Okay, any question? If not, we're going to look at the next concept, which is negation. Okay, number 4, negation of a conditional statement. And again, this one is the one we sort of already touched. Let's see. Well, I'm going to save a little bit, maybe one line right here, because I'm going to put the formula right there later, after the example. So we're going to look at example. Well, you can use the one I just mentioned. If I live maybe, okay, I'm sorry, I'm gonna change it. If I get a 93 or higher, well, if I get a 93, then I will get an A. Right, so we're gonna do the negation of the whole statement. Well, what is the opposite of this statement?
If I get a 93 and I will not get an
I would not, well, I did not get an A, right? Yes, exactly. So the common mistake I had before is a lot of students thought, okay, if I don't get a 93, then I don't get a A. That's not right. Okay, that's not a negation. So the negation will be you did get a 93, but you didn't get an A. That would be the negation of whatever. If I have this on my syllabus, then that would be the negation. So the negation is we actually get rid of if. Okay, so what actually happened when suppose I have this statement on my syllabus, and the real situation is I got a 93, but in English we use but. In mathematics, but is the same as and, no difference, right? So but and I didn't get an A. Okay, so does this example make sense to you? Yes? Okay. Or the other examples we have, if it snows, the class will be canceled. The negation will be, it snowed, but the class was not canceled, right? So that would be the negation. From these examples, you can see right here, what's the formula? How do we do the negation? Suppose we call this, this is the hypothesis, and that's the conclusion, Q. So we have a P implies Q. I got a 93, that's still P, right? Notice the hypothesis in the negation of a conditional statement, the hypothesis does not change. Then, look at the conclusion. Original conclusion is I will get A. In the negation, say I did not get A, right? So that's what symbol do we use that? Not a Q, right? Oh, I'm sorry, I shouldn't use, and. What's the symbol for and?
Upside down B.
Yes. So although you say but in real life, but is the same as and in logic. That's the symbol. So we do have to pay attention. Originally it's a conditional statement, but negation we change it to an and statement. So let's see. Let me write down the formula. So the formula says the negation. If we do the negation of a conditional statement, it's equivalent to keeping the hypothesis, change the implication to and negate the consequence. So that's the formula. I mean, some of you may not have to memorize the formula. You can just do it like James. You can just do it by common sense. Okay, this is what later I mentioned it on Monday that we're gonna do proofs, and one of the common techniques is proof techniques is indirect proof. We say proof by contradiction. So that's what we're gonna use. So if they ask you to prove something like if this and if this and that, then if this and this, then you would prove something and something. But you may not be able to prove it directly. So maybe you would say, okay, if this and this, then that something else doesn't happen. Then you get a contradiction. That tells you that this has to occur. You don't have to worry about this too much. But what I'm saying is later we will in later chapters we will use this negation in the proofs. Again, chapter 1 is just gonna lay the foundation. We learn some logic to be used in the later proofs. Okay, and so we can do. I'm trying to see. Do you need? Well, we can do a quick example here. That's example 1.2.4. If my car is in the repair shop, then I cannot get to class. Now, what's the negation of this statement?
If my car's in the repair shop, then I can get to class.
Yes, that's right. So my car is, get rid of if. So my car is in the repair shop and I can get to class. So we're keeping the hypothesis. My car is in the repair shop. We changed then, we got rid of if, we changed then to and.
Could you move your paper around?
Oh, okay. So I cannot get to, will become can get to, right? So you got to negate, so kind of follow that formula we talked about. Do you need one more example for this? No? All right. So we're going to move on to next concept definition. So this section, it has a lot of definitions that you have to memorize. So far negation, I think it's not too bad. So there are some three concepts we're going to talk about next. It's called contrapositive, and a converse and inverse. So there are three definitions. First, let's look at well, let's maybe go ahead leave one line there. I'm going to go ahead and put these three together so you can compare them. And the next one is called a converse and inverse. These are talking about conditional statements. Let's look at a converse first because I think this is the easiest one. So converse says, if you have a statement P implying Q, what's the converse? You switch the hypothesis and the conclusion. So you're going to get Q implies P. That's the one we talked about before. If I get 93, then I will get an A. If I get an A, then I must have 93, right? So that's you switch the hypothesis and conclusion. We call that converse. Now, inverse is you're not going to switch the hypothesis and conclusion. You're going to negate both of them. So you negate the hypothesis and you negate the conclusion. So that's the one we talked about at the beginning. If you show up for work, then you will get a job. And many of us in real life, we assume if I don't show up for work, then I will not get a job. That's actually called inverse of the conditional statement. They may not be equivalent. They may not mean the same thing. Now the last one, go back to contrapositive. So the contrapositive will be doing both operations. Not only you have to negate both hypothesis and conclusion, but also switch them. So after you can do either way. You can first switch them and negate them. So put a negation in front of Q, put a negation in front of P. Or you can do negation first. Danielle, can you shut the door, please? Thanks. Or you can do negation first and switch them to get that. Right, so you sort of have to, if you have never heard of these names before, you have to memorize them. Inverse is you negate both of them. You negate the hypothesis, you negate the conclusion, but you don't change the order. Converse, you don't do negation, you just switch hypothesis and conclusion. Contrapositive, you got to do both. Okay, not only negate, but also switch them. Okay, all right, so we're gonna look at some examples doing all these three of them. If we can look at this one here, example 1.2.6 part B. If today is Easter, then tomorrow is Monday. Right. This statement is true, right? Okay. Later we will talk about whether a true statement, when you have a true conditional statement, whether the contrapositive is still true, or converse or inverse will still be true. Right now, let's just try to practice these concepts here. So we can do converse first. So what is the converse of this statement?
If tomorrow is Monday, then today is Easter.
Yes. If tomorrow is Monday, then today is Easter. All right, now let's look at inverse. All right, what's the inverse?
Today is Easter, then tomorrow is not Monday.
If today is not Easter, then tomorrow, well, is not Monday. So converse, remember you only switch the hypothesis and the conclusion. So you switch them. Inverse, you have to negate both of them, but don't switch. The next one is contrapositive. You got to do both. Okay, so what is it?
If tomorrow is not Monday, then today is not Easter.
Yes. If tomorrow is not Monday. So you start with the consequence and negate it. It's not Monday, then today is not Easter. Okay. Any question about this? All right, and in the, I'm going to give you one more example. Although these, if you memorize the definition, this is easy. But the next example, we have something like that in the homework. We will combine a conditional statement and a conjunction or disjunction. So you have to not only apply what we just learned, but also the negation of conjunction and disjunction before. So we're going to do, the next example we're going to do is that one we can do the homework. We can take a quick look at the homework here. So the homework question number for number 20, 22, 23. By the way, you don't have to do, for number 20, you don't have to do all of them. They have a lot of them for number 20. They have A, B, C, D, E, F, G, so 7 questions there. You only have to do A and D and F. So you don't have to do all of them, 7 of them. But for these 3 questions, you do, for these 3 questions, you got to do negation, which we just talked about, and you got to do contrapositive. Number 22, you still have to work on these 3 questions. You don't have to do the other ones. do contrapositive, do converse, and inverse. So the question we're gonna talk about is this one. What if there is or in the conclusion or and in the conclusion or in the, it could possibly in the hypothesis. So I'm going to give you an example. Let's say if that's the homework, it's not in the homework, it's on the back of the exercise. So we can do this question here. If x is non-negative, then x is positive or 0, or x is 0. Let me write it out. X is 0. Okay. We're doing the same thing here. Converse. So remember converse, what do we do? Change, yes. Change hypothesis and conclusion. So you're just going to copy if x is positive or x is 0, then x is non-negative. Now, inverse is the one we have to be careful. Inverse, we're supposed to negate both of these. Negate hypothesis. So originally we have hypothesis x is not negative. So we negate that. What do we get?
X is negative.
If x is the negation of non-negative. Well, you can say negative is negative, or you can, if you want, you can add not. If not non-negative, right? If not non-negative, which is the same as x is negative. Then what?
Then x is not positive or not.
There's a small mistake there.
Oh, yeah.
Okay, so that's the common mistake. So that's why I'm saying you got to be careful there. Or we had an or, right? In the conclusion, we have a disjunction there. If you remember De Morgan's law, when you do negation of that, you have to change or to end, right? So the conclusion would be then x is not positive.
And x is not 0.
Yes, very good. Okay, that's the place you got to be careful there. Change or to end. Remember that? So when by De Morgan's law or just common sense, when you have when you negate a disjunction or statement, neither of them will occur. So you have to change or to end. Positive, of course, you got to negate both of them. Positive becomes not positive. 0 becomes not 0, but or is going to be changed to end. Similarly, if I have and here, you got to change it to or. Okay. The last one, contrapositive. Okay, so what is contrapositive?
If x is not positive and x is not 0, then x is negative.
That's right. So if x is not positive and, notice that you have to change or to and x is not 0, then x is positive. Well, if you want to say, x is negative. And not non-negative. All right. Any question? Okay. So let me circle the places. Got to be careful here. Change or to end. The next thing we're going to talk about is only if. That's number 8. So we talked about if P then Q. But there's also something said only if P, then Q. Only if P, then Q. Or sometimes we may just say Q only if P. That is the same thing. I just changed the order of these two. Say only if P, then Q. That's the same as Q only if P. What is the difference between only if P, then Q, and the one we just discussed before? Compare with what we talked about before. If P, then Q. Is there a difference? We can give a real-life example. If it snows, then the class will be canceled. When I add only in front of it, only if it snows, the class will be canceled. Is there a difference between these two sentences?
Yes.
Yes. Okay. This one we use the symbol P implies Q. A lot of times we use symbols to help us see, to have an easier way to look at the logic in there. So let me give you the example we just discussed. If it snows, then the class will be canceled. Compared to the second sentence, only, I add the word only in front of it. Only if it snows, the class will be canceled. Okay, what's the difference?
The first one is more than one of the class can be canceled.
That's right. Okay. So the first one, it says, if it snows, then the class will be canceled. So let me ask you this question. If it doesn't snow, is it possible for the class to be canceled? Yes, right? Okay, maybe. So I think, again, in real life, you may think, well, I think this one probably not as bad as the previous example. If you show up for work, then you will get a job. A lot of times we assume if you don't show up, then you won't get a job. Although that's not the case in logic. Well, like I said, real life you may assume that, but not the logic, correct logic. In this case, I think it's easier for us to understand. If it doesn't snow, the class may still be canceled, right? For example, if the instructor is sick, or the power is out, whatever, so the class could still be canceled. So it's snowing is just one of the possible conditions, hypothesis for the class to be canceled. So there may be other ways. So if, the inverse, what we just talked about, if it doesn't snow, the class will not be canceled, then that's not necessarily true. Okay, if it doesn't snow, the class may still be canceled. Okay, but look at the second one. Only if it snows, the class will be canceled. So if it doesn't snow, will the class be canceled? No. So even if the instructor is sick, the class will not be canceled because the second statement says only if, when you have only, that's the only hypothesis or condition for the class to be canceled. If the instructor is sick, you still have to come to the class. Maybe they found somebody else or some other way. So that's the main difference between these two. Okay. Well, how do we describe by symbol? Using a symbol to describe the second one. We know the first one, P implies snow implies class to be canceled. The second one, you cannot do that anymore. Well, I mean, you can do that, but actually the second one, the symbol we're going to use will be switched. Okay. Yeah, maybe I could use the symbol S, snow. For the first one, snow implies class to be canceled. But for the second one, you actually have to switch them to class will be canceled will imply snow. Yeah, think about that. How can we use the symbol to describe the second one like this? So although we said if it snows, only if it snows, then the class will be canceled. suppose you, if I tell you the class is canceled today, what conclusion can you get? What can you deduce from that? Based on the second statement.
It's snowing.
It is snowing, right? Because snowing is the only condition. So if the class is canceled, you know for sure it must have snowed, okay? Because there are no other conditions. But when you have the first statement to say when the class is canceled, can we conclude that it must have snowed? No, it could be, the instructor was sick, or the power's out, or other possibilities. But when you have only, if the class is canceled, you know that must be because of the snowing, okay? So that's why you can say class canceled. If the class is canceled, then it must have snowed, okay? As you can see, when you have only if, you switch the hypothesis and the condition, the conclusion, okay? So be very careful about that. And a lot of times later, sometimes in the mathematics, we have statements like only and if only if, okay? So we often say if and only if. So both of them are true, which means S implies C. Snowing implies canceling classes. Canceling classes implying snowing. And I think, all the definitions you learn, it's always if and only if. Both are true. And in real life, some of them are like that. For example, if you show up for work, although we say if you show up for work, then you will get a job. It's actually, you are assuming they're saying showing up for work, getting a job if and only if you show up for work. Although we don't say only if, but we automatically assume it's only if. Okay, but again, in mathematics, you do have to say it clearly. In real life, you may not, but so there is a difference between these two. And okay, now let's see. Next thing we're going to talk about is some more definitions we call sufficient and necessary sufficient condition for Q. And again, maybe leave one line there. And number 10, necessary condition for Q. Okay, sometimes instead of saying if and only if, for example, we could say something is a sufficient condition for something else. So you would say for a shape to be maybe for a quadrilateral to be a rectangle. We may say it this way: if it is a square, then it is a rectangle, right? Okay, if it's a square, then it's a rectangle, but not the other way. But so you can say the sufficient condition for a shape to be a rectangle is a square. It is a sufficient condition. So that is enough for a shape to be a square, to be a rectangle. So it's just a different way to say sufficient condition. So what is a sufficient condition? So when you have P implies Q, a conditional statement, we call P a sufficient condition. So, or you can mark P as sufficient. So as you can see, P is the hypothesis. The hypothesis is called a sufficient condition for the consequence. I'm going to give you more examples in a second. But necessary condition is the other way. Suppose it's like only if Q implies P. So we call this way, we call P, the conclusion, a necessary condition. So which means this must occur. Just like if what is a necessary condition? When you say only if it snows, then the class will be canceled. So if you know it is snow, if the class is canceled, then it must have snowed. So that's something necessary. And maybe let me give you more examples to explain this, so you have a better idea what this is. So we can look at example 1.2.9. So if John is eligible to vote, then he is at least 18 years old. So in this case, we call the hypothesis, like I said, in the definition here, the hypothesis, John is eligible to vote, is a sufficient condition for him to be at least 18 years old. So is to ensure. So if you know John is eligible to vote, you know for sure that he is at least 18 years old. So that is sufficient for that condition. So we call John is eligible to vote. This condition is sufficient, is a sufficient condition, or you can say it's sufficient. To ensure that he is at least 18 years old. Another example I gave you before, maybe better than this one. If you get a 93 or higher, you will get an A. So getting 93 or higher is sufficient for you to get A, right? You don't need any other requirements, nothing else. So we say that's sufficient. That's enough. Sort of like we say that's enough, right? So if you show, if I see your average is 93, you will get A. So that because that is sufficient. I'm not gonna look at anything else. Okay, so that's sufficient condition. Next is necessary, and we say, well, we can look at the same example. We will say John is at least 18 years old. That's a necessary condition for John is eligible to vote. Or I can use the example that we talked about. So 93. Well, let me continue this one and give you the other one. So you would say John is at least 18 years old, is a necessary condition for John is eligible to vote. Okay, so the easy way for you to remember the definition, sufficient and necessary, is the hypothesis. When you have a conditional statement, the hypothesis is always going to be if sufficient, called sufficient. And the conclusion is called necessary, because that must occur. So like the example I said, if you have 93 or higher, if you get 93 or higher, and you will get an A. So we call this sufficient, because having a 93 or higher is enough, so sufficient. And then you get an A, that's necessary. That means that must occur, right? So if you get 93 or higher, you're getting an A will definitely happen. Okay, so that, or like why we call it necessary. Okay. I have 5 minutes where we can do example. So this, like I said, in math, sometimes we use different ways to say the statement. We say if and then. I think that's the easiest way to understand, but sometimes they don't say that. They may say the sufficient condition for a number divided by 9 is that this number is divisible by, for a number to be divisible by 9 is that this number is divisible by 3. So that, they may say that way, but actually what they're saying is, if a number is divisible by 3, then, I could probably get it backwards. If the number is divisible by 9, then this number is divisible by 3, okay? So for a number to be divisible by 3, the sufficient condition is divisible by 9. Okay, so we can look at this example that I just said. So the sufficient a number is divisible by 9 is sufficient for a number is divisible by 3. So that's a different way to say that. We want you to rewrite this. In if and then condition sentence. I want to rewrite it as a if-then statement. Okay, so how do we rewrite this?
If a number is divisible by 9, then a number is divisible by 3.
Yes. If a number is divisible by 9, then this number is divisible by 3. Okay. Oh, I probably should use this here. And how do we do that? What you need to do is, like I said, when you see sufficient, what is sufficient? This is sufficient, right? So which will make this hypothesis or consequence? What does it make a sufficient condition?
Sufficient is always
Hypothesis, right? Okay, so this is going to be hypothesis. So that's why you put it first. That's your hypothesis. Okay, but if I change, I can change it to the other way. A number is divisible by 3 is necessary for this number is divisible by 9. Now we want you to change it to if-then statement. So rewrite it. In this format, if-then. Okay, so what is it? How do we do that?
If this number is divisible by 9, then a number is divisible by 3.
Right, it would be the same, right? Because when you see necessary, that makes this what? Conclusion, right? So if this is conclusion, the other one has to be the hypothesis. So you will still get the same thing. If a number is divisible by 9, then this number is divisible by 3. Okay? All right, I think that would be all for today. If you have trouble doing the homework next Wednesday, you can ask me in class. I can't hear you. No. Later.
Your meeting has ended.